Hey guys, hello everyone and welcome to the channel. Welcome to the solution of part B physical chemistry question. So here in this video I'm going to take all the questions asked from physical chemistry in the part B of CSIR net December 2023 exam, that is all the 2 marker questions. These are all memory based questions, so some questions might be like partially written or like there must be something which are missing from the question, but I have tried to come up with the things whatever I remember for the question, and we'll come up with the solution at least, okay, or come up with the answer at least, so that you can match your answer and get a idea that how much marks you are getting in section B, especially from the physical chemistry part. Okay, so having said that, let's start from the first question. It was asked that for 0.001 molar solution of AlCl3, CaCl2 and KCl, the correct order of Debye length is. Okay, now the question was from Debye length and the concentration was given to you and 3 salts are given to you. All have the same chloride ion, but the metal ion are different. In the first one you have aluminum in +3 state, in the other one you have calcium in +2 state, and in the other one you have potassium in +1 state. Okay, now Debye length, that is lambda d, is given by epsilon kbt divided by 2e square z square Na and multiplied by the concentration, okay, and under root of this. So this is how you calculate the Debye length. So basically, if you see here, if all the other things are constant, that means if temperature is constant, concentration is constant, in that case the Debye length is inversely related to 1 by z. Z is basically the charge on the cation, or if the anion is same, then the charge on the cation. Okay, so over here you can see that if the charge is more, z is the charge, higher the charge, smaller should be its Debye length. So according to that, aluminum chloride AlCl3 should have smallest Debye length, followed by calcium chloride and followed by potassium chloride. So your correct answer should be your option number A. Okay, so option A should be correct option. Okay, the next question where it says that the stepwise polymerization of correct order of plot of chain length, that is n in this average of n, against degree of polymerization. So remember, there are 2 graphs related to degree of polymerization. One graph is for the weight average or the number average molecular mass and the degree of polymerization. This curve looks like this, okay, whereas the curve where we see the number average molecular where we see the chain length or the average number of the monomeric unit related to the polymer degree of polymerization, this curve is given like this. Okay, it starts from a certain value, certain non-zero value. So correct option is option number B. All right, let's see the next question where it says that molecule B is twice as heavy as molecule A. The ratio of thermal de Broglie wavelength of molecule A to that of B is. So thermal de Broglie wavelength is given by lambda, and that is equals to h upon under root 2m kbt. So the temperature is constant, kb is Boltzmann constant, h is Planck's constant. So you can say that thermal de Broglie wavelength is inversely related to under root m. Okay, now you have 2 conditions. You have 2 conditions: the mass of A or Ma, okay, let's say it is m, and the mass of B, molecule B, is twice as heavy as A, so it is 2m. Okay, the thermal de Broglie wavelength corresponding to this, let it be lambda A, and corresponding to this is let it be lambda B. Okay, so the value of lambda A will be, or lambda A will be proportional to 1 upon under root m, whereas lambda B will be proportional to 1 upon under root 2m. If I take the ratio, it says that the ratio of thermal de Broglie wavelength of A to that of B, that means we have to do lambda A divided by lambda B. So that will be 1 upon under root m divided by 1 upon under root 2m. Okay, if you solve this up, you can write it down as 1 upon, or you can simply solve it in this way, that it will be equal to 1 upon under root m multiplied by under root 2m upon 1. If you solve this, you will get root 2 upon 1, which is equals to root 2 is to 1, and the correct option is option number A. So it was pretty simple question, pretty straightforward. I hope you all have answered this correctly. The next question was based upon group theory. It was asked that mx5 belongs to D3H point group. This was the molecule which was having D3H point group. Okay, D3H. Now it was asked that if the elongation is done along the equatorial bond, one of the bond is elongated or both of the axial bonds are elongated, what will be the point group change? So here if you change or if you increase because in D3H the principal axis is going through this, okay, this is your principal axis, C3 axis. Here also if you elongate the bonds along the axial axis, then also this C3 axis is going to remain like that only. You will be having C2 axis and you will be having the plane which is sigma h plane. So the point group is going to be remain D3H itself, okay. So the point group is not going to change in this case, but here the point group will change. Now the principal axis will be this axis and this will be a C2 axis of symmetry. You won't be having any horizontal plane now, you will be having vertical planes. The point group is going to become C2V, okay. So the point group of this side becomes D3H and this side becomes C2V. The option which was having these two things is going to be the correct option. I don't remember the exact options, but yeah, this should be the answer for this, okay. All right, let's take this question here. It says that H is equals to, that is Hamiltonian is given to you. This is px square and divided by 2m plus vx, whereas the value of you have to find out the commutation of h and px, okay. So if you solve this h comma px, you are going to get, you have to write it down or you have to operate it on a wave function first of all. So let's say that is psi, so you will get h px psi minus px h psi, okay. If I substitute the value of h, which is this, you can even convert this value actually. If you convert this value, it will be easy for you. So px is minus I h cross d by dx, okay, and px square will be equal to minus h cross square upon h cross square and d2 by dx square, okay. So h is going to become, or Hamiltonian is going to become minus h cross square upon 2m and d2 by dx square, okay. This will be the value of, and plus of course vx will be there, okay. So I am going to use this value instead of the other one. So if I substitute it, this is going to become minus h cross square upon 2m d2 by dx square plus vx, okay. That's the value of h. The value of px is minus h cross minus I h cross d by dx, and then I have psi, okay. So if I operate psi on this, this becomes psi, okay, minus, then I put the value of px, that is minus I h cross d by dx, and the value of hx, which is minus h cross square by 2m d2 by dx square plus vx and psi, okay. So if you now open the bracket, this is going to become minus h cross square upon 2m d2 by dx square plus vx, okay, and you will be having minus I h cross d psi by dx, minus minus will become plus I h cross d by dx, and here now you will be having minus h cross square by 2m, this will be d2 psi by dx square plus vx psi, okay. Now you have to open the bracket completely. So if you solve this up, or if you open the bracket completely, yeah, let me take it to the other side, this is rough. So here this part is going to become, if I multiply with it, so it becomes minus minus will be plus I h cross cube upon 2m d3 by dx cube psi, okay. When I have multiplied this with this, plus this will be, sorry, plus and minus will be minus I h cross vx into d psi by dx, okay, plus now I will solve this part. This, if I multiply these two terms, so this plus and this minus is going to make it, is going to become, so this is going to become minus, and this will be I h cross cube d3 by upon 2m will also be there, d3 by dx square psi. When I will multiply with it, so it will become plus I h cross d vx psi okay, by dx. So this is product rule. Now you have to apply the product rule here. There are two functions in the product form. First, before doing that, these two terms are going to get cancelled out easily. You will be having minus IH cross Vx d psi by dx, and you will be having plus. Now when you will solve this, you will get IH cross d psi by dx, okay, and plus IH cross sorry, now you are using product rule, right? So product rule, what do we do? First of all, we differentiate one of the function. Let's say Vx is not differentiated, psi is differentiated, plus let's say psi is not differentiated and Vx is differentiated. Okay, there is shortcut to solve this, but I'm doing in a trivial manner and it is not difficult. That's why I'm doing it. Okay, so d psi by dx, and plus when you open this, it will be IH cross Vx d psi by dx and plus IH cross psi dvx by dx. Now you can again cancel out this and this term. So basically when you started, I'll do it here. So when you started from h comma px psi, it became IH cross dvx by dx psi. Okay, so you can remove psi from both the sides. So the value of h px will be equal to IH cross d Vx by dx, which is your option number A. Okay, so option A is correct option for this. I hope this is clear to you. The next question is easier one. It says that e to the power ikx is eigen function of px with the eigenvalue. So you have to tell the eigenvalue. You know that the value of px operator is minus IH cross d psi by, sorry, minus IH cross d by dx. Okay, that's the value of px. And the value of psi is, let's say, e to the power ikx according to the question. If I operate this px on psi, this will be minus IH cross d psi by dx, or if I put the value, so it will be minus IH cross d by dx of e to the power ikx. Differentiate this, it will be minus IH cross differentiation of d by dx of e to the power ax is a e to the power ax. Okay, so whatever is in the coefficient, that will come like this, and e to the power ikx will remain as it is. So it will become minus I square h cross k e to the power ikx. So you will see that my I square is minus 1, that will remove this minus sign, so it will remain h cross k e to the power ikx, which is h cross k psi. So when you operate px psi, you got h cross k psi. So that means this h cross k is the eigenvalue, and that's option number B is correct. Okay, that's how you do eigenvalue equation, and that's correct. Okay. The next question is from Micellization. It says consider the statement micelle form above critical micellar concentration and micelle form above Kraft temperature. Both these statements were correct. Micelles are formed above critical micellar concentration, so the concentration of the monomers should be higher than this critical micellar concentration in order to formation of micelles. Also the temperature, if the temperature is raised, if that Kraft temperature is the minimum temperature that is required for micellization to happen. So if the temperature is higher than Kraft temperature, then only micellization will take place. So both these statements were correct statements. Okay. The next question was easiest one. You have to tell the allowed transition. So basically your spin selection rule should be followed. Spin selection rule says that spin multiplicity should not change. Okay, spin multiplicity should not change. Should not change. Now you will see that spin multiplicity is changing in first and in second. In third and fourth, it's not changing. Then you have Laporte rule. Laporte rule says that the value of delta L should be either plus or minus 1. Okay, so when you are doing from S to D, for S, you know that L values for 0, 1, 2, 3. For S it is 0, for 1 it is P, for 2 it is D, F. So when the transition is between S and D, the difference in the delta L value is 2. So that is also not allowed. But when the transition is between D and P, spin selection rule is already followed. but between D and P the delta L will be -1, which is allowed. So option D is correct option for this. Okay, let's take the next question. It says that for a proton of gyromagnetic ratio, the gyromagnetic ratio is given to you, and this is gamma 26.752 into 10 to the power 7, okay, radian per Tesla second, and the Larmor frequency is being asked when the magnetic moment or the magnetic field is given to you 21.1 Tesla, okay, 21.1 Tesla. The value of Larmor frequency gamma or omega, sorry, omega is the Larmor frequency, that is equals to gamma, that is Larmor the gyromagnetic ratio multiplied by your magnetic moment divided by 2 pi. Okay, because it's in radian, that's why we are dividing by 2 pi. So it becomes 26.752 into 10 to the power 7 divided by multiplied by 21.1 divided by 2 into 3.14, and this is going to give you something like 898.34 into 10 to the power 6. This is going to give you answer in hertz. In order to convert in megahertz, this will be 898 megahertz, or approximately equal to 900 megahertz. So correct answer is option D. All right. Okay, let's take the next question. Based on the Arrhenius equation, relationship between k and 1 upon t. So Arrhenius equation you all know, it is k is equals to a e to the power minus ea upon rt. If I take log both sides, it becomes log k is equals to, or let's leave this part, let's see like that only. Okay, so if let 1 upon t is equals to let's call it as x, okay, 1 upon t, so that I can plot the graph between k and x directly. So k will be equal to a e to the power minus ea upon r into x, right? So what will happen if x is equals to 0? If x is equals to 0, at that time this whole thing will be e to the power 0. E to the power, anything to the power 0 is 1, so only a will remain, so k will be equal to a. And if x is equals to infinite, if this becomes infinite, in that case the value of k is going to become a e to the power minus infinity, and anything e to the power minus infinity, value of e to the power minus infinity is 0. So this term is going to become 0, 0 multiplied by anything is going to become 0, so k will be 0. Now if you plot the graph between k and x, which is basically 1 upon t, okay, x is considered as 1 upon t, right? So if x is 0 or 1 upon t is 0, in that case k is very high, and if it is infinite, in that case k is 0, so you will be having a graph like this, okay, something like this. So that graph is the correct option. If you have that in the option, that will be the correct answer. Okay, the next question was that given orbital correspond to what? Okay, there were different options like HOMO of this, LUMO of this, something like that. So for this you have to first of all find out the number of nodes. So you just have one node here, so this correspond to second energy state E2, and cyclopentadienyl has how many energy levels? 5 energy levels, right? You have E1, E2, E3 and E4 and E5. So now if you are talking about cyclopentadienyl cation, okay, for this you will be having how many pi electrons? Only 4 pi electrons. So you can fill it like this, right? Whereas if you talk about cyclopentadienyl anion, in that case you will be having 6 pi electrons, and they are going to be filled like this, right? So this E2 is HOMO of cyclopentadienyl cation. E3 is LUMO of cyclopentadienyl cation. Okay, I hope you understood. Whereas E3 will be HOMO of what? HOMO of cyclopentadienyl anion, and E4 will be LUMO of LUMO of this same thing. Now in the question, the orbital which was, it was corresponding to E2. So E2 is nothing but HOMO of cyclopentadienyl carbocation. So the correct answer will be the option which says HOMO of cyclopentadienyl cation. Okay. Okay, let's take the next question. It says that for FCC of a monoatomic solid, the number of tetrahedral and octahedral void is how much? It is very simple. You know that for FCC, number of atoms per unit cell is equals to how much? That should be equal to 4, right? Number of tetrahedral void is equals to 2n, which is equals to 2 into 4. This will be 8, and number of octahedral void is equals to n. This is equals to 4. So the answer is 8 and 4. Okay, very simple, very straightforward answer. I think this was the easiest question of the whole question paper. The last question was from thermodynamics, 13th question, and over here it says that the equation, okay, what is the value of x? So this is from second thermodynamic equation of state. Okay, so second thermodynamic equation of state. If you know this, you could have answered this very correctly. The second thermodynamic equation of state says that you have dH by dP at constant T. Okay, well, the derivation you will actually get it. This is equals to T ds by dP at constant T and plus V. While derivation you will get that, although we convert this according to the thermodynamic relation into minus dV by dt at constant S. But let's not do that. Let's leave it till here, because these are the terms which we need. Now this is, I need this side. I have to bring all the other things to the other side. So if I take V this side, it becomes minus V plus del H by del P at constant T is equals to T ds by dP at constant T. Okay. Now if I bring this T to the other side, it becomes 1 upon T minus V plus del H by del P at constant T is equals to del S by del P at constant T. If I compare both the things, so the x correspond to minus V, and that's your correct answer. Okay, so these were 13 questions from physical chemistry and from section B, that is 2 marker questions. I hope whatever we discussed made sense to you. You have understood everything quite in a lucid manner, I would say. We have not discussed the things in much detail, but I think you got the point that how to solve such questions. It was physical chemistry of section B was very easy. Okay, it was very simple this time, and I believe that all of you who have studied physical chemistry might have attempted all the 13 questions of physical chemistry. They were super simple to attempt. Okay, do let me know if you guys want the solution of inorganic portion as well, and if you guys remember questions, please you can drop that down in the email ID provided in the description of this video. Okay, so I will be able to get more questions from section B. So that's all from my side for this video. Thank you so much for watching, and I will see you guys in the next one. Till then, have a great day. Bye bye, take care.